Solving equations using graphs. Let's do this. So we've got this graph, y equals x cubed minus x squared minus 2, already drawn, and we're being asked to use the graph to solve this thing equals 0. Well, actually, what this is the solution to is if you had y equals x cubed minus x squared minus 2, and you were looking at where it intersected y equals 0. So it's this, I'm going to even draw the line in. I'm kind of overcomplicating it here, but yeah, it's the intersection of this blue line with the curve, or you can just see it as being the point at which the graph crosses the axis. You know what, that might have been, the easier way to see it, but I did want to link in the fact that we can sometimes solve simultaneous equations to solve these equations, and that's going to come in a minute. So we just need to read off the graph. Me putting that little dot there actually makes it harder to read, so I'm going to get rid of it. Okay, I need to work out each one of these little squares is actually 0.05. So this is 1.6. This is going to be 1.7. Okay, this is where the simultaneous equations really come in. So because we've got a different equation now, but it's kind of related. And this equation can be solved by finding the intersection of the graph that we just drew with a different line. Find the value of A and the value of B. So what I can do here, just like I kind of did it here, if this is the case, I can set these equal. I can do the same in this situation. I can basically set x cubed minus x squared minus 2 equal to ax plus b. So how does that help? Because I've got x cubed, this is just there going on in the background of my head really. I've got x cubed minus x squared plus 5x minus 6 equals 0. And what I need to do is manipulate the left-hand side so that it becomes this thing here. So what can I do? I can first of all minus 5x. I'm going to take this slow. Okay, I've got minus 5x there. And now what can I do to both sides? To get that minus 2, I could add 4. I'm going to actually write that down. Add 4 to both sides, and that's going to give me x cubed minus x squared minus 2 equals minus 5x plus 4. And the solution to this equation here is the solution to the intersection of y equals x cubed minus x squared minus 2 and the line y equals minus 5x plus 4. So A is going to be minus 5 and B is going to be 4. Okay, and hence I'm being asked to then solve it, given my answer is correct to one decimal place. What does that mean? It means I'm going to have to actually draw the line y equals minus 5x plus 4. Okay, this is an equation in the form y equals mx plus c, where c is the y-intercept, so it's going to go through here, and then m is the gradient, so it's minus 5, so it means as I go along 1, I go down 5. So actually my next point is going to be here, because I'll do the dotted lines, I've gone along 1, we need to look at the scale carefully, and then I've gone down 5. I can do it again. I can go along 1 to 2, and then down from minus 1. No, that's not actually going to work. It's not going to fit on. Okay, forget that. I don't really want to do it going that way. And I can't do it above really. So maybe, just maybe, instead of going along 1, I'm going to go along a half, and then go down 2.5. That will work okay. That's all right to do that. And I could even do the same here. I could go along a half and down 2.5. So that's going to give me a really good line to draw. Okay, I've done it like that because I don't have a ruler, but now I'm gonna like shift it to make it work. Okay, pretty good. All right, now what was I actually trying to do? I was trying to find the solution to an equation which is equivalent to the solution of where these two graphs intersect, but it's just the x value I'm interested in. So I'm basically interested in the x value of this intersection. And if I read up, it's kind of in between, but it should be a range of values accepted. So I think it's going to be 1.2. I reckon I'll go with, yeah, 1.2 seems a good shout, and there should be like a range of values around that would be accepted.